So thank you. Good morning, ladies and gentlemen. My name is Christophe Hof, and I'm working for the Agentur for Innovation in der Cybersicherheit, Cyberagentur. Since 1st of July 2024, I'm the head of the project office of the agency in Dresden. And I will give you, in this keynote, an introduction to the Cyberagentur itself. And also I will talk about our largest program, one of our largest programs, formerly Verified IT, and its opportunities to strengthen cybersecurity and digital sovereignty of Germany. Additionally, I would like to introduce some thoughts on formal verification as a new paradigm in cybersecurity in and for Germany. But just as a reminder, these are just first thoughts of the team of Sebastian Jester, who, unfortunately for us, but fortunately for him, is back in General's Federal Research Ministry, but we believe that we'll still be in contact with him and that he will always also be within this group and work together. From my team, Christian is here, and he's now running the EvIT program until we get a new boss for him. In this general introduction, I will present an overview of the Cyberagentur, its strategy and its principles. I will do this as the Cyberagentur is part of this new paradigm and way to solve problems within cybersecurity, and therefore can also be seen as one part of this new paradigm tackling cybersecurity within Germany. We are an institution funded by the German government with the aim to strengthen cybersecurity in and for Germany. The main goal is to support and enhance Germany's digital sovereignty, or to make at least a decisive contribution to it. And how are we trying to achieve this goal? We try to find innovative and disruptive ideas which may bring cybersecurity and digital sovereignty to a next level. So we are looking for the golden nugget, which may be the game changer for the future or lead to decisive advantage in cybersecurity in 10 to 15 years. We first identify possible research questions which are not solved today and which could have great impact on cybersecurity for the future. And then we fund and respectively research these questions and we evaluate the research. But why are we as Cyberagentur doing this? And on behalf of which organizations are we doing this? The Cyberagentur was founded in 2020 in Halle by the German Ministries of Interior and Ministry of Defense. In the years leading up to 2020, many ministries had determined that ensuring digital sovereignty is essential for security of a country and that Germany needs to improve its efforts in this area. For this reason, the Cyberagentur was founded as a limited liability company and thus an agency rather than a governmental organization, so that it would not be bound to regulations that apply to governmental organizations. Greater agility, new approaches to procurement, and attractiveness as a younger employer are just a few examples for these reasons. The Cyberagentur is an interdepartmental agency and is owned and funded equally by the two ministries. Its task is to identify innovative and disruptive technologies for the day after tomorrow. Its principles are the obligatory focus on cybersecurity, and projects must always be geared towards the needs of the organizations of internal and external security. The main results must always be dual-use technologies, and the Cyberagentur is not involved in the research or development of weapons. The Cyberagentur supports competitiveness in its projects and aims to groundbreaking research, as this could lead to the desired high-level reward for the future. Identification of upcoming trends and weak signals in a very early stage to identify the right research questions is one of the tasks of the Cyberagentur. As fundings comes from German ministries, the focus is aligned with the German national cybersecurity strategy, and the research aims to increase cybersecurity overall for state, society, and also for the economy. As we have to look 10 to 15 years in the future, our applications-oriented basic research is at TR level 1 to 4. Therefore, we do not solve current problems of the cybersecurity, as this is, for example, the task of the Federal Office for Information Security of Germany. We look far in the future, which can be very challenging with respect to cybersecurity. But, and this is very special for Germany, we are allowed to fail in a high number of cases, which means up to 90%. But even a failed project leads to a gain of knowledge. We always look for a holistic approach and are trying to combine different scientific domains. Thus, our team consists of mathematicians, physicists, computer scientists, engineers, but also economists and social scientists. We see us as a project sponsor plus, which means we have the ability to assess and evaluate the research results of our partners. We have to use public procurement law, but we use it in very innovative ways to increase competition within research. As we are funded by the German government, we acquire the IP rights for Germany for later use. Our projects are developed in close coordination with our users, which are always organizations of the internal and external security of Germany. For every project, there must be a person out of this organization who confirms the necessity of the project and accompanies it as a possible user. The institutions we commission include research facilities and universities, as well as large corporations, medium-sized companies, and startups. Regionally, we are limited to Germany, the EU, NATO, and also befriended nations, as our focus lies on strengthening digital sovereignty of Germany. Here is the Cyberagentur in a nutshell. Financed by 2 ministries with the goal to ensure technological sovereignty. Very low TR level, but also allowed to fail in a very high number of cases. Our research budget was up to now roughly 60 million euro per year only for research projects. With the new legislations, we hope to get around 90 million per year for research projects. We give contracts and no grants, and as compensation, we get shared IP rights from our partners. We use innovative procurement methods, and after a certain period of time, we go only for the most promising solution. The ideas for the projects are always developed on basis of the need of our customers, which are police, military, but also the Federal Bureau of Federal Office for Information Security of Germany. But what are the subjects our research projects are assigned to? We have identified 15 cybersecurity topics within which we identify, fund, and evaluate research projects in the following 3 key areas. In the research area of key technologies, we investigate in fundamentals for applications in the other areas, and we focus also on major technological trends that could influence cybersecurity in the future. The topics of this department are cornerstone for the cybersecurity of the future. So we look into research questions regarding cryptology, we investigate different areas related to quantum technologies, we look deep into autonomous systems and swarms, we try to find new ways to communicate in a safe and secure way, and we finance research on cybersecurity through and for AI. The research area for secure system applies and further develops modern technologies and evaluates cybersecurity from the system of systems perspective. It brings together various areas and research fields and combines them to new applications. Research questions include, for example, how IT systems can be made safe and secure in the future, which are used by government, by public administration, but also by operators of the critical infrastructure. We want to know how the security of IT systems can be guaranteed and what future IT systems might look like. The third research area, the secure society, has a more non-technical focus. It takes a holistic approach to researching cybersecurity, focusing not on technology itself, but on people and society. This department also has the largest proportion of researchers with a scientific background outside of the traditional technical areas. Through its project, the department aims to make both state and society more resilient to the threats of tomorrow. One idea is also to increase not only traditional resilience, but also to reach vigilance, which means people's alertness in the digital world itself. Research on interaction between human and machine, on the cyber resiliency of societies, on digital identities, and on digital consumer protection is financed here. Additionally to the three existing areas, the Cyberagentur founded a project office in Dresden. The office combines three security topics of the three research areas and tries to combine them into a trustworthy technical value chain. Starting from trustworthy communications, which is part of the key technologies, one can set a framework for secure communications. Based on this, trustworthy IT architectures and supply chains can be built up. This topic was taken over from the secure system and aims to examine the trustworthiness of software, hardware, chip design, and associated supply chains. And here you can also find the project EvIT, which I will talk later on. At the end, trustworthy products have to be provided to the people and the society, and therefore digital identities and consumer protection in the cyberspace of the secure society build up the endpoint of this technical value chain. And why did we build up this project office nearby the main location in Halle? This was due to the fact that the region around Dresden is, besides Munich, a very relevant region for chip production in Germany. Additionally, companies specialized in automation, communication, and intelligent sensor systems can be found here, and many research institutes and renowned universities are located in Dresden. Last but not least, the Federal Office for Information Security has a branch office in Freital near Dresden, which also deals with telecommunications and hardware security. And therefore, the setting for the project office of the Cyberagentur is more than good, since there is an existing and vibrant ecosystem for IT security. Let me now come to a few unique selling points of the Cyberagentur in comparison to other organizations. This is an overview of our currently running research programs. With this, you can see the broad spectrum of research questions the Cyberagentur is working on. In the area of the secure society, we investigate new ways of biometric authentication methods. We try to develop a new brain-computer interface which is non-invasive and allows computers to be controlled by human thoughts. We investigate the effects of cybercrime, consider future variations of cybercrime, and attempt to develop an objective assessment of the damage caused by cybercrime. In the area of the secure systems, we investigate ways of increasing the cybersecurity of critical infrastructure and explore alternative computer architectures. Additionally, the program EvIT is run here. For the key technologies, we are investigating new methods of encryption and research the fundamentals of mobile quantum computers. In this area, we also have a program on robust and secure machine learning, which I will explain a little bit in detail because it also tries to combine methods of formal verification up to some extent. AI is increasingly used in everyday life and is influencing all areas of our lives. Having this in mind, the Cyberagentur set up a program which deals with robust and secure machine learning. Attack vectors on an AI could be the dataset, the training of the model, as well as the model and its implication itself. The program looks for new models, architectures, and mechanisms to build robust and secure machine learning processes. It's all about the robustness and reliability of data, training, and system processing. And within this program, 2 research questions will try to examine the extent to which formal verification methods can be also used and applied to machine learning. Existing approaches to formal verification of ML models are designed for neural networks with a lower number of neurons. Given the high complexity, these approaches are not yet scalable to deep neural networks with several million neurons and many hidden layers, as used in deep learning. Research questions of these programs are therefore, which properties of an ML model must be formally verified for safe and robust application of the application case? What are the limitations of formal verification? Which methods, approaches, and metrics are suitable for the formal verification of ML models, and how can the problem of state explosion in the verification of complex models be meaningfully addressed and the scalability of existing approaches increased? With this, you can see that we try to combine different specialties and research areas within the cybersecurity area and so build new solutions for our problems. In the following, I would like to show you a special feature of the Cyberagentur when awarding programs or projects, as the Cyberagentur has pioneered this approach in Germany for the sector, which is somewhat being bound to the German public procurement law. We use the pre-commercial procurement procedure. Aim is to strengthen the competition in research and development projects. The goal is to reduce the number of participating partners in the continuous process and thereby increasingly focusing the possibilities on a final solution that is best suited to the respective investigation. When implementing a corresponding program, the Cyberagentur generally proceeds in 5 phases according to the slide. In phase 0, the research questions are announced and all interesting applicants can submit a brief concept for solving the research question. An internal jury selects the most suitable applicants among the submitted solutions. These are then asked to prepare a detailed concept and a project outline to tackle the research question. For this project outline, the applicants are paid by the Cyberagentur, and in return, the Agentur acquires at least the rights to use the IP, so shared IP rights. At the end of the stage, workshops will be held with the applicants to find the best concept to solve these problems. This leads to a further reduction of the applicants down to normally 2 to 3, which then start with the main research phase and the main competition. After 1 year of intense research, another quality gap reduces the participants for the large 3-year research phase by another time. And the remaining participants in phase 3 can now use the following 2 years to develop, for example, a final demonstrator. At the end, there's also a possibility to give the winner another half a year to bring his final demonstrator up to the next level, which is like a additional add-up for the winner of the whole process. Especially during the research phase in phase 2 and 3, there is a continuous monitoring and support for the research project by the staff and the scientists of the Cyberagentur, which is our role as Project Sponsor Plus. The amount of money you can see on the slide is based on one of our XL projects, which means our biggest projects we fund, which has a volume of around 40 million for the whole research project. It is also possible to deviate from this procedure described here, as we have done also with the EvIT program. Here, all contractors know each other and are working parallel on the same fundamental research questions, but in partially overlapping research areas and using different approaches to solve the problem. Within EvIT, no competition is taking place, as we wanted to get a huge variety of solutions and tools and thus expand the solution space at the end of the project. At the end of this part, what are the unique selling points of the Cyberagentur? We try to think out of the box, and we try to anticipate what might be important in 15 years with respect to cybersecurity. And this is unique in Germany, in German institutions, and also especially in German institutions which are funded by the government. We finance research projects that venture capitalists would never invest in because the risk is too high and the business case is often really not clear. Oh, yeah. This allows us to finance innovative, disruptive ideas and niche areas that others neglect. For us, a project that fails is an opportunity to learn that, based on current technological knowledge, the relevant question cannot be yet answered, which is also a fundamental insight. We always have to think and work interdisciplinary and cross-departmental, and we always must have in mind that a stakeholder from the field of the internal and external security supports our research questions. Now, having said enough about the Cyberagentur, I will come to the EvIT program and our thoughts of the new paradigm of provable cybersecurity. So here's a new paradigm from the program title, Provable IT Security. And normally at this point, we would spend some slides on formal verification, which I will skip in this audience. I think it's the best way. I will directly go into the EvIT program and show you the 5 project partners which are commissioned by us to do the research. To support provable IT security, we launched the EvIT program ecosystem, formerly Verifiable IT. Actually, that idea came from the Ministry of Interior. The Cyberagentur was charged with funding a research into holistic formal verification of security properties. This means for both hardware and software through co-design and code verification. Security by design has been a buzzword for a long time, and so we can make it real maybe with this program. Part of getting there is, we believe, more automation and better scaling of formal methods. In technical terms, we would like to see a verified OS for multi-core systems, an open source one so you can inspect it fully and so it can be adopted widely. And in the long run, we would like to see verified desktops and servers. We have to look 15 years in the future. That's the thing. We know it's really hard. We divided the research questions into 5 domains. Ideally, we wanted the holistic approach of domain 1. However, we were not sure whether we would get all of this in one single proposal by a single consortium. And so we split up into further domains for software, ISA, and hardware verification respectively. Within the software domain too, we look for interoperable tools, proof engineering, combination of proven security features for complex systems, especially multi-core. In the hardware domain 4, we look for chip design for demonstrable non-functional properties and also for the reference architecture for trusted systems. In the software hardware domain number 3, we looked for end-to-end security through co-design and co-verification and for compositional verification of CPUs, drivers, and devices. And additionally, we look for the hardware supply chain for automated end-to-end reverse engineering and comparison of the finished chip with its specifications. Domain 0, at the bottom, is the cross-cutting platform for community building, fixing a common reference architecture and reaching out to industry, including for standards. Ultimately, research only comes alive when it's transformed into products. This is also one of the main goals of EvIT, to build up this community of formal verification within Germany. We then invited concepts that would address one or all of its domains. As it turned out, we received a set of 5 concepts that are very nicely complementary to each other, and I'm going now to talk about the project partners. Two of the projects we fund are based on SEL4, and you have already heard from these as 2 of the protagonists are here. The first one is Cry10. It's a Cry10 project with Proofcraft as a subcontractor. The project is now Christian Converse, and it aims to allow running SEL4 on multiple kernels. The second one is Pistis 5 with the Munich-based SME Plan 5 as the main contractor, and Gernot Zeiser team at the University of New South Wales as one of the subcontractors, and the University of Gothenburg as the other one. I want to highlight the prevention of Spectre and Meltdown-style timing attacks with a single processor instruction, the special processor instruction FANS-T. Then there's also the automation of driver verification. Three projects do not build on SEL4, but take other approaches. The Barkhausen Institute in Dresden is tackling a holistic verification with an approach based on Rust to ROC transpiler. They want to use it to verify a unikernel operating system on a RISC V-based processor design, all in a single proof system. You may criticize that Rust has no verified compiler, and you will be right, but there are always turtles somewhere. The Protect project, headed by the German AI Research Center, uses the opposite approach. Bottom-up verification of individual components in whatever proof approach suits best for the component, and then compositional verification of the whole system. They use virtual prototyping of hardware to do hardware-software co-design. They are interested in the prevention of timing attacks too. Importantly, the community building is part of this project, and we really believe in the potential of formal verification. So we want to use the community building both to network our projects with a larger number of the community, and also to promote the formal verification and the use of it. And we also want to bring it into industrial applications. So these are the 2 biggest projects, as you can see by the number of partners. The smallest one, the 5th one, is Clash Formal by the Dutch company QBayLogic. They have a functional hardware description language based on Haskell, which is called Clash. And so they said, let's see whether we can use it for formal verification of our designs and of software running on them. The 5 projects, I will now go with one slide all upon. Converse is a project by Cry10 in collaboration with Proofcraft. It aims to enable a new class of embedded and cyber-physical systems with formally assured support for updatable multi-core systems built on the verified SEL4 microkernel. For multi-core, they will use a multi-kernel configuration of SEL4 with a separate SEL4 kernel instance per core. For zero downtime software and configuration updates, a privileged user update component that provides a high-level API for authenticating and executing update commands will be developed. For formal assurance, the project develops theorem-proving frameworks for verifying kernel-level correctness of multi-kernel configurations and user-level correctness of privileged components. A major verification challenge is the concurrency amongst multiple kernel instances and user space threads. Pistis 5 aims to develop an embedded system that demonstrates end-to-end security and safety proofs and can serve as a starting point for industrialization. It is based on Lions OS, the operating system built on SEL4 microkernel. The project will provide an approach to develop drivers for Lions OS and verify the drivers against the verified implementation of the device hardware. It will also verify other critical hardware components, including the FANS-T instruction. The verified properties of Lions OS will include the proof that untrusted components can be confined. A core aim of PISTIS-V is the easy re-verification of new drivers and policy modules required for porting the systems to new platforms or adapting to new use cases. This will be enabled using push-button verification techniques. Formula V aims to create a fully formally verified system that meets the highest standards of security, privacy, and trustworthiness. One key approach is to align formal assumptions made in software with corresponding proofs in the hardware. A cornerstone of the project is the development of a unikernel system, a minimalist operating system architecture designed to run on a single application arm. By incorporating only the necessary components, such as minimal file system support and networking capabilities, the design reduces the attack surface and optimizes performance. Each layer of the unikernel is subjected to formal verification, enabling rigorous guarantees of correctness and robustness across the system. The semantics of a RISC V processor and the implementation of the unikernel will be transferred into ROC for formal verification. Furthermore, countermeasures against side channels and transient execution attacks will be introduced. Protect focuses on a compositional bottom-up strategy, where different formalisms and approaches are combined into one unified system. The development of the project's reference systems will be based on a RISC V core, which will be modeled with virtual prototyping. Protect will investigate methods for seamless generation and verification of security properties using SAIL as an ISA specification language. This approach allows early co-design and verification of software and hardware. New formal verification techniques for the hardware and the hardware-software interface will establish a secure microarchitecture as a root of trust in order to avoid transient execution side-channel attacks. The startup Crispin is developing tools to verify Rust programs, including the Hex toolchain and a verified cryptographic library for Rust. An important part of this project is the community building, to design and facilitate a community of researchers, hardware and software developers, and also practitioners from industry. If you're interested in the progress of the EvIT program, we just invite you to follow us on the LinkedIn page, which you can see on the link here. The last one, Clash Formal, its mission is to enable the applicability of formal verification tools such as proof assistance or SMT solvers, not only for functional programs, but in the same fashion for intrinsically parallel functional circuit designs. Clash Formal leverages the functional hardware description language Clash in combination with the functional programming language Haskell for the creation of safe and secure correct by design hardware, hardware to software interfaces, and software within a single all-in-one description language and development environment. The Clash compiler transforms high-level functional hardware descriptions into low-level synthesizable VHDA, Verilog, or System Verilog. One goal of the project is the direct integration of formal verification frameworks like the language SAIL for describing the semantics of instruction set architectures, as well as interfaces to proof assistance such as COC into Clash and Haskell compilers. The results finally are used to create a security token and an advanced smart card reader demonstrator with formally verified system properties. This is the whole EvIT program, and with this I just want to show you, we try to build a tool set at the end which we can offer our customers, our users, and hopefully then bring them to use formal verification and bring it to a next level also in Germany, because here we're a little bit, let's say, backwards to other countries. Let me go on. Maybe this would also be a new cybersecurity paradigm with formal verification who still needs certification. The following considerations were first triggered by an SEL4 summit talk 3 years ago in 2022 that Sebastian Jester attended. And to his recollection, someone either from a car maker or a car processor maker asked him, why do we need to worry about variable naming conventions to get certificate when we can formally prove the functional safety and security? Such tick box exercises should not count more than formal methods. Many subsequent discussions have raised similar points, and the need to recertify updated parts of complex military goods with long lifetime certainly gives my colleagues from the armed forces headaches, especially having in mind the new software-defined defense bubble which comes up in the military right now. So why does this cause headaches? Because we live in a regulated and also in a way where you only can get in when you certify something. You have to certify everything which is related to aerospace industry, to car industries, to cybersecurity, and to medical, for example. The problems are always we have very high cost for the evaluation, for setting the process, and also for keeping the documentations updated. This is a very high barrier for small companies. We are also very slow because we cannot go the update cycle which nowadays updates of the software updates will go on. So solution also could be, why not specify the properties formally and formally verify the product's conformity? With formal methods, we can prove that the source code or hardware design corresponds to the requirements. You all know this. Certification on the right-hand side looks nearly the same. At least the certification of if a certification of a product and not of a process is desired. In real life, certification many times also looks at processes, in particular in quality management processes, which are often certified as such. Quality management processes may also be required also to get certain product certifications. Maybe also we can recall the new paradigm to formal certification, which is a bit shorter than certification via formal verification or formal methods. Has this been tried before? Yes, but in our thought, not successfully. This idea has been around for some time, but there aren't many scientific papers to be found about here. Here we put together a few which we caught and which also caught our attention. If you know more, please let us know. There's one paper by Wozing et al. From 2010, so not really recent. And it's a firm call to product level certification rather than certifying only the software development process. The quote to me maps well into formal methods. Certification should be a measurement-based activity and in which an objective assessment of a product is made in terms of values of measurable attributes of the product using an agreed-upon objective function. The objective function is the formalized spec. The objective assessment is done by the proof assistant. The research question the paper sets out seem to have stood the test of the time, as I do not see them fully answered. It is remarkable that they imagine a faking of real processes for the purpose of certification. But this paper also shows, like Bolt Molterer always said, they draw the attention to the fact that the creation of software should be an engineering discipline rather than tradecraft. So it should be a mathematical discipline. These guys, Dupont and the others from Belgium and Italy, look at recertification of software against common criteria. They conclude the exact inverse from Wozing, that a certified process is the only way forward, in particular if you want fast recertification. When they say incremental certification in the second quote, that already means when there is a security update, isolate those components that are affected by the update and recertify only those rather than the whole product. Even if we subscribe this approach, how would we show that the rest of the components are not affected by the update, if not via formal methods? In any case, sticking to process verification because product verification is too hard seems like the anecdote of the drunk person who loses his key in the dark but looks for it under the street light because he cannot see it in the dark. This is from Sebastian Jester. He always gets some of these. Back to the product-based approach. Andisetti et al. Show that model-based formal certification works in principle, but they run into the same problem and the same hurdle which we are familiar with. The computational complexity is so high that formal methods do not scale. There do not seem to be too many recent papers on the topic of automatic certification. One we found is the one by Caxonen et al., but they use standard IT security tools to automate tests from ETSI standards for IoT devices. But at the end, this turns out that this is more testing than formal verification methods. Two questions. Would formal certification work technically, and can there be a business case for this? The technical case is there. Product-based formal certification allows fast recertification. The technical problem is then very similar to the formal verification of hardware and software design systems. That has enough challenges of its own, which we are addressing in our EvIT program and which you all are addressing in one way or another. A variant of full formal certification is using the formal methods to show that if you changed one part of the system, the rest is not affected at all or only affected in a certain way. And then you can recertify a smaller part of the whole system. Is there a business case for this? A business case for using formal methods is often hard to make. However, certification is expensive as well. Establishing it requires processes, having the required documentation, and doing the evaluation and certification itself. That all costs a lot of money. We hear regularly from universities or small enterprises that we should not require standards compliance in connection with our research programs because certification is so expensive. If your product is developed using formal methods anyway, then you are already bearing that costs. It is then much more attractive not to bear the certification costs as well. So we were also interested in your thoughts about this, and maybe if we can also get some talks about together, and also if we can raise new research questions with respect to this topic to bring formal methods more to an end. Before I close, some ideas where formal methods may also help. One is legislation. It happens that two laws contradict each other. Often national laws need to implement supranational legislation. Here in the EU, the so-called directives are rules adopted by the EU which need to be translated into national laws. If you want to be sure, and you also have to be sure, and you want to be sure of mutual consistency. And here, automation using formal methods would contribute to better lawmaking, possibly. The other area is supply chains. The beauty of formal verification is that you do not need to trust the supplier if you can formally verify that the software or the hardware design is secure, with one big caveat for the hardware. I will come on. Maybe formal methods can also be used within the supply chain methods, but the big caveat about hardware is that we need to analyze the hardware itself, because we really cannot trust all the suppliers, all the manufacturers, and all the manufacturing steps. So what could be ways, unless physically destroying the chip, if we want to get insights of the chip and if it's really safe? Thank you for your attention, and I'm now waiting. Welcome to comments and questions.
Yeah, thanks for the interesting presentation of the topic at the end about the sort of the tension between formal certification and formal verification, the terms that you used. I'd just like to say that I don't think you can ever replace the certification process that you want to do with formal verification completely. And so I think it's potentially going in a wrong direction to overemphasize that. The issue is that you will always have some human element involved with building a safe and secure system. The issue on the safety side, for example, is that all of these safety processes tend to be driven by a risk management process where there's hazard analysis, which is essentially a brainstorming activity, thinking about how the things could go wrong with the system, deriving the requirements from that, and then starting the process that you're envisioning. So there's always going to be some human element involved. The same thing on the security side, right? It's coming up with the appropriate threat modeling. And then once you get the threat modeling in place, then it's designing your security controls. And so if you shift and you try to present things totally in terms of a focus on automated and formal verification, you will miss the opportunity for steering research in the direction that supplements the human activities and their integration with the formal activities. That's my general comment on that sort of thing. You'll also have, in the context of the full certification process, I mean, there are a lot of sort of processes that are set in place to manage the human elements, you know, establishing appropriate safety culture in the organization, or even things related to managing distributed development. So a lot of the processes are associated with things like, if you have a supplier, making sure that suppliers' defect management and notification of defects, that information gets properly propagated to all consumers of the component that's being incorporated. I mean, that's fundamentally a management issue, right? It's not a formal methods issue. And so I would just say, you know, in this whole story, it's perhaps more productive, instead of thinking of things in a strong binary between process-oriented and product-oriented, to think more precisely about where exactly the formal stuff comes in, how the formal stuff can be supplemented by, you know, automating the suggestions and the brainstorming processes on the human side, for example, to more deeply and better integrate things like the hazard analysis, the threat modeling, and things like that.
Yeah, thank you. We have the same thoughts, and therefore also we have this department of secure society, because we know that besides all these technical issues, we have also always the component human, which cannot be controlled anyway. So I'm completely with you. We have to find where could formal certification work, but where also we have to still stick to the old rules. That's completely right. Yeah.
So when he was starting, at first I thought I was going to disagree with part of it, and then by the end I'm like, no, I totally agree. I totally agree. One of the places it can help is, as even in a new device, if it's reusing components that have been previously certified in other devices, can you identify those components? Can you show that they are unchanged from previous certification paths, and thus try to reduce the scope of the work without reducing the human element of doing the brainstorming? That's still got to be there, but can we use formal methods to reduce the impact of any given release, and especially the updates where most of it's the same and then there's very small changes? Can we identify the changes both in terms of which applications changed and which communication lines changed, and focus the humans on the valuable part instead of having them redo all the grunt work every time? Anyway, it's a comment, not a question, sorry.
Okay, let's thank our speaker again.